All right, so a pleasant evening to everybody. Welcome back to another semester, another term. Mathematically, we have about 4 months to go, right? But in the interim, we're going to have whole of like extra something now go on, right? Whole of like extra something now go on. So we have a marathons and come up, we're gonna do a review paper. So we have that to deal with, right? So last in the latter part of last term, when I told you that we had Sunday classes, those Sunday classes were designed specifically to try to make up for some hours that was lost due to the Hurricane Melissa, right? We don't have them Sunday classes anymore. At least we not have them anymore. However, though, however, however, what I'm going to do is that I'm planning to use those Sundays to do extra class. All right, planning to use those Sundays to do extra class because we need the practice. We need the practice no more. Like we need it, right? Not me, not you, and not me, we both of us. I need you to pass, and you need to pass. So we're gonna use those Sundays to do our. I already spoken to Miss Morgan and she gave me the go ahead to continue with the Sunday class. However, it's going to come at a small fee. Now because me know say the hurricane really hammer no, me not charge no not more than $300. Everybody is me charging five. But me just are charging $300 and it's going to be for 2.5 hours. I think you can get a better deal than that. $300, $300 for an hour and a half. Can we say an hour and a half? Because it's not going to be a long class, but it's going to be like a whole session. So I will reach out to you and send you like an official message in the group, and I'm going to just charge you $300 for the hour and a half to 2 hours of practice every Sunday. You don't have to come every Sunday, but when you can, you come. If me have 5 on, I'll work it. If I have 10 of you guys, I'll work it. I will just practice some questions together. All right, based on what we're teaching. And they're all going to be past papers questions and exam structured questions. All right. I will let you know how you can pay whether online or you can go down by the school. It's up to you. I'll let you know. Okay. But for now, just know some have a nice little thing or plan for now. School are gonna be with daily life in the next 4 months. So please brace yourself for that. Okay? Please. All right. So without further ado, we'll have to dive into what we need to do for tonight. We can't itch, we have to start the teaching tonight. Okay? All right. Yes, it's online, Nisha. I have face to face as well, too, but I don't think any of you guys are going to be accessible on a Saturday at 12 o'clock because most of you guys are adults on work. So if you want to come face to face, I have it on Saturdays at 12. It's looking like 12 p.m. in the day. So if you'd rather a physical contact with me, you can come on Saturdays. All right. And if you come to 1 minute, I'm going to charge you for both. I don't know. This depends. All right. So we'll talk about it further because it's going to be effective January the 17th. Well, January the 18th. Effective those 2 days going forward, I'll be having extra classes every Saturday and every Sunday. So you're free to join me, okay? All right. Let's get into it. Any question before we move on? No question? All right, cool. Let me see who else in the waiting room will come in. Nobody else? All right. Okay. Oh, Sasa, you're here. Hi, Sasa. All right, so here we go. So, picking up from where we left off, let me pull up my whiteboard. I will send you an official message, ladies and gentlemen, to summarize everything that we have talked about in the last 50 minutes. So, fret not thyself. All right. The 17th of the 12th. Wonder if I this another. 29th of the 12th. That was me. 17th. 21st of the 12th. Check this. 15th. Can somebody remind me what was the last thing that we did? Let me just pull up the right board.
We were looking at multiplication
like,
and division for algebraic terms.
That was the last thing we did, right?
Yes, sir.
All right. So I'm looking at a screen right now we looks like we were talking about coordinate geometry. All right, boom. Oh, and I think this was the time where I said to you guys, please ensure that you watch that video and we summarize some stuff here. So I think this is what we were doing at one point. Yeah, see there. And I said that, guys, make sure you watch that video to summarize everything. So we're done with that topic there. And you said that we're doing algebra, right? Let me just remove that. And so that was at the 15th. So the 15th now would have been, let me check the 17th and see what happened. All right, so on this now, okay, so I see what was going on. Okay, so look in your book and tell me if this is what the last thing that you saw.
Your screen is not showing anymore, sir.
Oh, it's not? Oh, thank you for telling me. Okay. All right, so tell me if this was the last thing that you saw. It's coming up. Does this look like the last thing that we were doing on the algebra?
Yes, sir.
All right, good.
Yes, sir.
All right, good. All right, good. I mean, I already did post this recording already, so it's out there for you to watch if you want to catch up back on what you're seeing on the screen. And I'm not sure if there's any new student in here. There should be maybe one or two. But if you're new, all my classes are recorded and they're posted on a channel. Can somebody post my channel link in the chat just in case somebody's new and want it? So every class I have is posted here. All right, so based on what I'm looking at on the screen here, we went through add and subtract, right? We went through multiply and divide. We went through all those, we'll look at those, right? Okay. All right, so tonight then we're going to move on to the distributive law. That's what comes next. All right, here we go. So for tonight's topic, we're going to be looking at the distributive law. All right. Alrighty, guys, let's go. So the distributive law. All right, so I'm going to pull up a little notepad here. I'm going to give a definition for this. All right, here we go, guys. Let's go. All right, so the distributive law states that the number or term that immediately precedes a parenthesis should be used to multiply the terms inside the parentheses. So the distributive law states that the number or the term that immediately precedes the parenthesis should be used to multiply the terms inside the parentheses. All right, so let's do an example of what that means. Let's just move this to the side here. Zoom it up a little bit. Right, beautiful. There we go. You can write out that in the meantime. So that's the rule. That's the rule for distributive law. You know my style already, guys. We take it from the basics and we build it up and make it become more advanced, all right? So let's start off with a simple example like this, number one. Now, let's put a number outside of a bracket. 2, open bracket, let's say x plus y. Now, we can't solve that, ladies and gentlemen, right? We don't know what the answer is going to be because we don't know the value of x, nor do we know the value of y. And as we discussed in our last class, we cannot add unlike terms. So there's no way to add x and y. Right? So the only thing that we can do here is to use the 2 to multiply the x and use the 2 to multiply the y. So we're going to end up then with a final result here of 2 times x is 2x plus 2 times y is 2y. Now you cannot add those together, guys. Remember we said that unlike terms cannot be added. So if you're thinking about adding 2x to 2y and to get 4xy, that's going to be vastly incorrect. All right, your answer is going to be 2x plus 2y. All right, so once you see something outside of the parentheses, you're going to use it to multiply whatever is inside the parentheses. All right, now in this example, that's just a number. If we look at example number 2, we can have a letter on the outside as well. So let's say you have something like x open bracket 2 minus y, something like that. Same procedure. We use the x to multiply the 2, and we use the x to multiply the y. Now, x times 2, you can write x2 if you want, but that's kind of weird, right? So x times 2, we don't write letters then number, we write the number then the letter. So x times 2 is going to give us 2x, and x times y is going to give you xy. X times so x times y is going to give us xy. All right, and then that's your simplified answer. That's your expansion. Okay, now number 3, we can have a combination of both. So we can have a number and a letter on the outside. So we can have something like 5p. I don't want to just use x and y and make it get too comfortable with that. So it can be any letter. So we can have 5p open bracket so we can have 5p open bracket 3 plus 2y. All right. So let's say you're asked to expand that. For whatever reason, you're asked to expand that. Now, again, 5 times p, we're going to go ahead and we're going to use the 5 to multiply the 3. We're going to get 15. And then you bring back the p, because 5 times 3p is 15p. Then we're going to use the 5p again now and multiply the 2y. So the 5 are going to multiply the 2, you'll get 10. And the p are going to multiply the y. You can write py or yp, it doesn't matter. In this case, I'm going to write py. I normally write my answers in alphabetical order, py. All right, so the answer is going to be 15p plus 10py. All right. Number 4, it could be negative. There could be something outside of the bracket then. We could have something like, say, minus 4 open bracket 3x plus 5 minus, something like that. Keep it simple for now. So we have minus 4 outside of the parentheses. And so because we cannot add 5 to 3x because it's unlike terms, we're going to use the minus 4 to multiply the 3x and the minus 4 to multiply the 5. We'll end up with an answer here of 4 times 3, that's negative 12, x. And then the negative times the positive gives us negative. Remember the negative outside here, so with the positive inside here, the negative and the positive gives us a negative. 4 5s is 20. And remember that, ladies and gentlemen, the terms are unlike, so you cannot add or subtract them. So nobody go say minus 12 minus 20 is minus 32x. No. The 12 has an x on it, the 20 doesn't, so they are unlike terms. All right? So be very mindful of that. All right, any questions thus far from those 4 basic examples? Any questions? Silence means silence is golden. Yes,
I have
question.
a question. For number 2, for the negative, why does the sign change outside here?
Thank you very much. That's a error on my part. Thank you. So it's 2x minus xy. Thank you very much. All right. Any questions on those 4 basic examples? Everything looking good so far? Okay. All right. So we're going to just draw a line here. And zoom up. Since we don't have no questions and I have no notes there, let's move right along then to the next phase. So then, obviously, now that you're going to sit on the exam. So the instruction you're going to see then is going to be this. Simplify the expression below. Simplify the expression below. 2 open bracket 3x. Let's write that a little better. Hold on. So 2 open bracket 3x minus y minus 4 open bracket 5x minus 2y. So that is most likely what you might see on an exam paper to simplify the following. So what you basically have, guys, is two distributive law in one. I'm going to use the 2 to distribute in this bracket here and use the 4 to distribute in that bracket there. Okay? All right, so go ahead. 2x times 3. Sorry, 2 times 3x. 6x. 2 times y. 2y. Minus 4 times 5x. Minus 20x. The negative on the 4 multiplies the negative on the 2y and give us a positive. 4 times 2 is 8y. Everybody good there, sir? That line?
Sure.
Yes, go ahead. Question.
The signs
Pardon me?
are there, even though the signs are there, you always have to multiply?
Yes,
Okay.
because that's the distributive law. Anything that's outside of a bracket should be used to multiply what is on the inside of a bracket. Yeah. All right. Are we comfortable with line 2? Everybody good here, sir?
Yes,
All
sir.
right. Now we're going to group like terms. So we did this when we started algebra. We learned how to put terms that are alike beside each other. So we're going to have 6x So we're going to group the terms together. We're going to have 6x minus 20x minus 2y plus 8y. And don't forget your O and half method. Remember, same thing that we did when time we just met me O and half, same thing you're going to do now. What is 6 take away 20, guys?
14, sir.
Negative 14.
Negative 14, sir.
All right, and what is minus 2 plus 8y?
10y.
Come again, check that again.
Wait, sir, minus
Positive
6.
6.
Minus 2y plus 8y.
Positive 6.
Positive
6y.
6y. Yeah. All right, and that there is your final answer. Cannot go any further. Once again, because the terms are unlike, you cannot go any further. Look carefully and see if you can find a question for me. You have any question or is it clear? Okay, no questions. Another example. Simplify 5x bracket 2 minus y minus 4 open bracket y minus x. It's not that. Let's do 4 open bracket x minus 4. X minus y. X minus 4, yeah. Something like that. So remember, once you see a bracket, ladies and gentlemen, no one in the future, especially if it looks like this, you use whatever is on the outside to multiply what is on the inside. Like that. So the 5x times the 2 is going to give us 10x. And then the 5x again times the y is going to give you minus 5xy. Now the negative 4 times the x is going to give you negative 4x. And remember that the negative on this 4 right here, so is going to multiply the negative right here. So that's going to give us positive. So watch your signs. 4 times 4 is 16. Now in this example, there's only 2 terms that are alike. If you look carefully, only this and this is alike. 5xy and 16, they're unlike. So you're not going to touch them. There's nothing you can do to those. So you're only going to go ahead and group the 10x with the minus 4x. Write down back the minus 5xy and put back your 16. So your answer is going to be 6x minus 5xy plus 16. And that's it. All right, so I'm going to give you one to try to see if you can get one on your own. So go ahead, guys. Using the example I gave you before, simplify the following. So simplify. I heard somebody said something. Oh, no? Okay. Simplify 5 open bracket 3x plus 2y minus 4 open bracket 7x minus y. Go ahead and strap up that one, please. I'm giving you 2 minutes. I'll give you 1 minute and 30 seconds. Go ahead. Give 9 seconds extra. All right. So your time is up. Let's see what you have. Right, let's see if you come close. Distribute the 5 on the here and here and there. 5 times 3x, that's going to give us 15x. 5 times 2y, that's going to give us 10y. Hopefully you're on the right path so far. 4 times 7x is 28x. And the negative outside with the negative inside becomes a positive. Hopefully you have that positive there. 4 times y is 4y. So now you can clearly see here that we have two terms that are alike. We have the 15x with the negative 28x. And we have the 10y with the 4y. Now you don't have to regroup it, You can just do it mentally in your head, write down the answer and get it out of the way. But I'm taking my time here. So I'm going ahead to say 15x minus 28x plus 10y plus 4y. All right. What is 15 take away 28?
Negative 13.
Excellent. Negative 13x. And what is 10? Well, self-explanatory. 10 plus 4 is 14. That's 14y. And obviously, we're not allowed to go any further than that because x and y are unlike terms. All right? I'm assuming that some answers are in the chat, as you guys always do. Yeah, man. Of course. So Sasadine gone with that one. Natalia gone with that one. Levon gone with that one. Ajir gone with that one as well. So Ajir, Miss Gentles, Samantha, Hanson, Natalia, Sasadine. And I'm assuming that other persons probably get it right. All right, so we're good to go. All right, so you get the basic idea. We're going to make it get a little bit tricky. All right, because, so obviously that's not just where it ends, right? That's the introduction to get you to understand that when we get those kind of terms, that's what we do. I'm going to give you a tricky one here. I'm going to give you a tricky one here, guys. So let's see. All right, so here's another one. Simplify all right. All right, so here we go. Simplify 5 minus 2, sorry. No, give me a second, guys. Let me see if I can restart my screen. It's kind of freezing up a bit here. Give me a second, guys. It's kind of freezing. I don't know why. All right, here we go. All right, so here we go then. We have 5x minus 2, open bracket, 4.
I'm sorry, we're not seeing the screen.
Thank you so much for telling me that. All right, confirm. Seeing the screen now?
Yes, sir.
All right.
Yes, sir.
So we have that question. 5 minus 2, open bracket, 4x minus 7. Let's look at some common mistakes that students make with this question. Right? Looks very simple, and it is when you understand it. But then there's a common mistake that always happens. One, you work the math, something you don't remember all the rules. So one of the mistakes here is that students often say 2 from 5x give them 3x. And then what they'll do is that they'll distribute the 3x and say that times that. Big mistake. All right. Why is that a mistake? 2 reasons why it's a mistake. One, you cannot subtract unlike terms. So there's no way you can take 2 away from 5x. That's not possible. At least not in algebra. All right. And 2, you cannot subtract before you distribute. You broke the rule of PEMDAS. So that's 2 reasons why that's an illegal approach. So you cannot say 5 from 2x. You cannot take this 2 from this 5x right here. Right? And you're not allowed to subtract before you distribute. So once the presence of a bracket is there, ladies and gentlemen, always try to remember to distribute. Now, another mistake that students make is sometimes they'll distribute from too far. So they'll do something like they'll say 5x times 4x, 5x times 7, then they'll say 2 times 4x, and then 2 times 7. And they'll do a bunch of different things. We don't want that happening, guys. The question is far more simpler than that. All right, far more simpler than that. So what we want now, ladies and gentlemen, is to understand a simple approach to this question. So here we go. What we're going to do is go back to the rules. If you go back to the rules, you'll realize that this was already explained. So if you scroll back up here and go back to the rules, what does it say? The distributive law states that the number or term that what? Immediately precedes the bracket. So it's whatever immediately comes in front of the bracket is what you should use to distribute inside the bracket. So that's why when I wrote the sentence, when I wrote the instruction, I wrote it and I move away from it because I don't want you to penetrate too much on that. So here, you can't take 2 from 5x, nor can you distribute the 5x over the 2. You have to bring back down the 5x, and then you're going to distribute the 2, the minus 2, like that. So you bring down the 5x, and then you say 2 times 4x, that's going to give us negative 8x. And then negative here, with the negative inside, gives us a positive. 2 times 7 is 14. So now, if you look carefully, these two are alike. So now we can add these two because 5x and 8x are of the same family, right? So we can go ahead then and say 5x minus 8x is going to give us negative 3x plus 4. And that's the answer. Right there. So hopefully that's clear enough for you. You grasp the concept.
Sir?
Yes, question.
All right. Negative 3x plus 4, or it's 14. Which one of them?
Oh, it's 14. Thank you. Thank you very much. All right, look carefully, guys. See if you can find a question. If you can't find any, it means that you understand. Do you see something on screen that is explained and you're not clear about it? Let me know. All right, no question. Move on to another example. Now we can do it the other way around now. We can put the number outside now. So we can say 3. We can say, we can say something like 7x, or let's use a different letter. 7y minus 2, open bracket, 5 plus 3y. Something like that. And you ask to simplify that. Again, temptation. You want to take the 2 from the 7? No, in fact, let me do it the other way. Let me just remove this. Move the y from here. I'm going to put 7 minus 2y. All right, so we have that question then. All right, I got it right. Write it better. 7 minus 2y. So we have that question. 7 minus 2y, open bracket, 5 plus 3y. So again, you cannot take the 2y from 7 because it's unlike. Secondly, you cannot subtract before you distribute. And remember, you cannot distribute over the term that is in front of the bracket. So again, you're going to bring down the 7 and you're going to distribute the minus 2y inside the bracket here. So minus 2y times 5, that's going to give us minus 10y. Negative times positive is negative. Remember the negative outside, guys, out here will affect the sign inside right in here. So negative by positive is negative. 2 times 3, 6. Y times y, we learned that from last class, that's y squared. And in this case now, we don't have anything to simplify. We don't have anything to simplify because we have the 7, which is a constant. We have the 10y, and we have the 6y squared. So in this case, your expression has been simplified to its lowest term. All right. Now I'm going to give you one to try, right, before I give you an advanced version for this. All right, let's go. So you can try this one for me. And again, I'm just going to give you a minute and a half. Or just a minute, maybe. Depends on the complex of the question.
Sorry,
All right, so go
just
ahead, guys.
a minute. How you
Yes.
get the squared? I lost
Oh,
sight.
the y times the y gives us y squared.
Oh,
2 times the 3, 6, and the y times the y, so y squared.
okay.
All right, cool. So go ahead, guys, and simplify for me the following. 1. 3x minus 2, open bracket, 4 minus 5x. And number 2. Number 2. 5 minus 9, open bracket, 3x minus 7. All right, so go ahead and simplify those 2 expressions for me. Oh, time. 2 minutes. It's 2 questions. All right. All right, your time has expired. Let's see how far you have or you were able to get. You can leave your answers in the chat. I'm going to check it shortly. So we're going to go ahead and distribute the -2 as expected. The 3x comes back down. -2 times 4, that's -8. The negative by the negative is positive. 2 times 5x is going to give us 10x. And you can see that the 3x and the 10x is the like terms. So when you add those, you're going to get 13x minus 8. And that's your answer. You can rewrite the third line and group them. It's up to you. For this one now, I set it up in such a way to tempt you, because notice that the 5 and the 9, they are both what? They are both like terms. However, if you subtract those, you'll be breaking one rule. You'll be subtracting before you distribute. So be very careful of this one. So I'm write it so that it tempted you. Go ahead and take -9 from 5 and get -4 and then distribute. So you have to go ahead and write down back the 5 and distribute the -9. So 9 times 3x, that's going to give us -27x. The negative times negative, this negative right here, with this negative inside here becomes positive. 9 times 7 is 63. And the previous example before, you realize that the x's were common. Now it's the numbers. So 5 and 63 are common. So the answer is -27 plus 68. Or you have 68 minus 27x. That's also correct. All right. All right. Look carefully to see if you see anything that I've done that you're not clear about and you want to ask a question. I'm going to check the chat to see what's going on over here.
We have a problem, you know.
The signs them I beat you.
I don't know what is it, but go back to the screen, please. Just bring it
Okay.
back.
Sign them.
All right. So we see Natalia and Zahenia got Zahenia got the answer before. Samantha also got that right as well. Right, and Dominic is getting that right as well. That's good. All right, Miss Stacia, what do you say?
All right, bring up back
What
the
did you do
screen.
wrong?
All right, so I have the 5 minus 27x plus 63. Down here now, what I did was minus the 5 from the 27, but I just
On like
realized
terms.
it's, yes, by itself. So I should just have 27x plus 68. Yeah.
That's correct.
Yeah.
So the mistake is just that sometimes you get caught by accidentally subtracting unlike term. That's why I emphasize so much on it.
Yeah,
That's a common problem.
All right, thanks.
All right, yeah, man, no problem. All right, let me check by the chat. See one over here. Oh, nobody else never respond. Okay, Dominic got it right, and Natalia and Zahenia. All right. All right, cool. All right, assuming that there's silence, I mean that everybody has probably got it and be like, all right, cool, sorry, everything good. No problem. All right, so now that we have those basics out of the way.
Sorry, you have
yes.
plus 63 and then you have plus 68. You'll make an error here, I would assume.
No. Oh, so the 5 is positive, you know, and the 68 is positive, 63 is positive. So when you add 5 and 63, you get 68, positive 68.
Also, what you're saying now, I get what you're saying. Yeah. All right, thanks.
Yes. All right, so let's put it all together then. We have all of these extra stuff going on here. Let's put it all together in one question. So here's a CSEC question for you. Simplify the following. Simplify the following. 3x. All right, 3 minus 8x, open bracket, 2 minus y, minus 5x, or minus 5, I should say, plus 2x, open bracket, 3y minus 4. All right, So I would put this on an exam. I don't think I've ever seen anything like this on CSEC exam. But the point is that we just want to understand how to work with expressions like this, in case we see them. All right. So does anybody want to volunteer to guide me through the steps? Don't be scared now. It's okay.
Yes, sir.
All right, go
Let me
ahead and
try.
talk to me.
Okay, so you're going to write back down the 3.
Mm-hmm.
Then you multiply it by 2, so you get 16x minus 16x minus and the minus plus, so you get a positive 8xy. And you write down minus 5 plus 2x times 3x. So you're going to have 6xy. And a plus times minus, you're going to have minus 8x. So
Excellent. Continue.
So we're going to go now. We have 16.
Just find the
16x. We
terms that
don't
are
have
alike.
16 minus 16x and minus 8x.
Mm-hmm.
We have 8xy positive and 6xy.
Very good.
A positive 3 and a negative 5.
Very good. Excellent. Continue.
So we're gonna have an 8 and 16 plus 8. We're gonna have negative, yeah. And we're gonna add the 6 plus 8xy. It's a positive 14. Positive 3 minus 5, we end up with negative 2.
Brilliant. Smooth like a silk. Lovely. All right. Excellent job. Perfectly executed. Can't ask better than that. All right. Anybody have any question? Did you see anything that was done and it miss you? Flew over your head? No. Going once? Going twice? And sold to the student who just brilliantly answered that question. Lovely. Fantastic. All right. If there aren't any questions, I'm going to move on to the next phase of our distribution technique. Now we're going to be moving on to what is called the product of binomial expressions. We're going to move on to the product of binomial expressions. So the product of binomial expressions. So to start this off, we're obviously going to need to know what is meant by the word binomial expressions. Maybe it's the second time you're hearing it or it's the first time. So we're going to grab a little notepad here and fix up the little thing. All right. So what is a binomial expression? That's the question. What is a binomial expression? Well, a binomial expression is a binomial expression is an algebraic expression consisting of two unlike terms. So again, let's just zoom this up here. So a binomial expression, what is a binomial expression? It's an expression, an algebraic expression at that consists of two unlike terms. So basically what we're looking at are examples such as 1, x plus 3. That's a binomial expression. X is unlike to 3. One is numerical, one is algebraically written. They're combined together. They're basically one term. So when you see x plus 3, you're not looking at x and 3. X plus 3 is one thing. X plus 3 is x plus 3. And there's several. You can make them up on your own. Number 2, it could be y minus 1. Again, it's not y and it's not minus 1. It's together. They latch on to each other. So y minus 1 is not y, it's not minus 1, it's y minus 1. This is one expression. And we can continue all day, all night. 3. A minus B. It can be 2 letters as well. So it has to be 2 different letters or a letter and a number. A minus B. A and B are unlike terms. And they're joined together. So A minus B is just what it is there. A minus B. All right. And then you have some funny looking ones that you might end up and see as well. You have some with some powers as well. So you can have something like, say, x squared minus or x squared plus 7. That's also binomial. The x squared minus x squared plus 7, that's also, because you cannot add them. You see, the moment you cannot add or subtract the two terms that are joined together, it becomes binomial. And then from those examples, you kind of get what I mean, right? So you can end up with something like number 5. You can end up with something like 3x plus 2y. That's binomial. It's 2 different terms. You can't add 3x to 2y. So 3x plus 2y is just what it is, 3x plus 2y. So if I were to go ahead and zoom back out here and look at all the answers that we got, realize that all our answers were always binomial. Yeah, they were always binomial. Look at the answers that we got up at the top. From number 1, minus 2x plus 2y, binomial. 2x minus xy, binomial. 15p plus 10py, binomial. Minus 12x minus 20, binomial. 13x plus 14y, binomial. Minus 14x plus 6y, binomial. Even when you have these 3 terms together, it's called a trinomial expression. Because of 3 terms, 3 unlike terms. So if it's 2 unlike terms, you call it bi. If it's 1 term, you call it monomial. And if it's 3, you call it trinomial. All right, but most of the time at this level, you're going to end up with a binomial answer. All right, so those are examples of what we call a binomial expression. Now, the next thing you're going to look at is what is the word product? What does product mean? Mathematically, product means to multiply. So what we're going to be learning how to do, guys, is learning how to multiply this term with that term. So it's going to say something like expand the following. So we use the word, we don't use the word multiply, we use the word expand. So when we're doing these things, guys, ladies and gentlemen, we don't use the word multiply. You're not going to see us say to you, multiply the following. We're not going to say that. We're going to say expand. So the first part is that I'm going to say to you, expand and simplify. Because after you expand it, you're going to end up with terms that are alike. So it's going to say something like expand and simplify the following. Expand and simplify the following. So what does this say? All right. So expand and simplify the following. 3x minus 2 and you have another bracket here that says 2x minus 1. Something like that. So 3x minus 2, 2x minus 1. Remember, you're not adding and subtracting, ladies and gentlemen. You are multiplying. So if you notice how this question looked versus the ones that we were doing earlier. The ones that we were doing earlier, we had a number outside of the bracket. Here, we don't have any number outside of the bracket. We just have two brackets joined together. So there's no number, as you can see, there's no number between here. So you can't use the number and say, this, no, there's nothing there for you to distribute. So how do we attack a question like this? How do we simplify this then? Pay very close attention to my arrows, guys. Watch where I go on. Let me use a different color ink. Tired of red now. All right, pay attention now, watch. So we're going to take the first term. Watch me now, We're going to take the first term. Oh, sorry. Ouch. All right, good. Ready. So we're going to take the first term and multiply it by that term right here. Turn the arrow here. Then we're going to take the first term again and multiply the second term. So watch out, look at the arrow. Pay attention to the arrow. Look at where the arrow is converging from and where it's spreading to. So the arrow converges at the 3x, and we're going to use the 3x to multiply the two terms on the right. So basically what we do is that we use the first term to multiply the outer terms. So we call it the FO. So the first to multiply the outer. So we use the first term and we multiply it by the two outer terms here. All right. Now what do we do next? We take the inner term so we take the minus 2 now and we multiply by the same two terms over here. So what we do now is that we take the inner term and we multiply it by the last term. And so when you go on YouTube or you type this thing in, what they are going to tell you about is the foiling method. So if you were to type foiling method on YouTube, then this is what's going to come up. How to foil an algebraic expression. All right. So, boom. So let's go ahead and do that. So pay attention now. Look at what you're doing. You take the 3x and you multiply it by the 2x. So that's the first one. So I'm going to put a little number here, number 1. I want a different color ink. Hold on. Give me a sec. So look at this now. 1. 3x times 2x is 6x squared. 2. Up this are 2. The outer arrow. 3x, look at the arrow it point to minus 1. So 3x times minus 1 is minus 3x. Three. That's number 3. That inner one there. Minus 2 times 2x is going to give us minus 4x. And then the last one, 4. This one. Minus 2 times minus 1 is positive 2. Now, majority of the time, if the question is written according to the structure of how I have it on screen here, you're going to find that most of the time your like terms end up in the middle. I'm not saying to you that that's always the case now. But regardless of how it wants set up, you must be able to identify. At this stage, everybody here should be at least able to identify when terms are alike or when they're unlike. Because 6x squared, there's no other square in this expression. But the 3x and the 4x, they're alike. They both have an x. and the 2 is a constant. So in this case, then we end up with a final answer here of 6x squared minus 7x plus 2. And that's your final answer there. Look at it good, observe it for a minute or two, or for a couple of seconds, and see if there's anything there that you might have missed. Like I did something and you're not quite sure how I got that expression.
Sir, suppose in the exam you forget to put on the X, you're not going to get the question right.
Put on the X where? On the 7?
Yeah.
Yeah, man, that's going to be incorrect. Because then minus 7 plus 2 is going to give us minus 5. Yeah, so if you left off the X off of the 7, you're going to end up with 6x squared minus 7 plus 2, which is basically 6x squared minus 5. And that would not be correct. I heard another voice in the background. Somebody else had something to say?
I was asking about the 7x here. The adding the 74 and the 3.
Remember that? Remember the negative what you owe, you know? So if you owe me 3, you owe me 4, how much you owe me in total?
Oh.
So we can't forget the rules of PEMDAS and our own having, because own have will follow you everywhere. All right.
Okay, sir.
Let's do another one. Expand and simplify. Three minus 5x 4x plus 2, or 4x minus 2, yeah. Let's do this one together. So look at where I'm pushing my arrows now. We take the minus 3. Sorry, we take the 3 and multiply it by the 4 here. And then we take the minus 3 and multiply it by the minus 2 over here. I can do those 2 first. So if you can't do it all at once, take time and do it. So let's go with the 3 times the 4x. That's going to give us 12x. And the 3 times the 2 is going to give us minus 6. So we do the first 2 terms. The 3 times the 4x give us 12x. The 3 times the 2 give us minus 6. Let's do the middle. Here. And then here. What is negative 5x times 4x? That's going to give us negative 20x squared. Don't forget your square, you know. Kind of 2x here multiplies to x times x, are going to give you x squared. And then obviously we're going to have the negative 5 times the negative 2. That's going to give us positive 10x. Now, like I told you in the previous example, I'm not saying that all the time you're going to have the terms in the middle. So I don't want you guys to run away from the class and say, oh, sir, say it's always going to be in the middle, and then you're going to make a mistake and go add 6 to 20 or subtract 20 from 6, negative 6. And you get the answer wrong. Remember, if you look at the 6, it's a constant. And the x squared is an algebraic expression. So there's no way for you to add those 2. If you notice that based on the structure of the question, the like terms end up at the end. So in this case, 12x plus 10x is 22x minus 6 minus 20x squared. So the like terms can end up anywhere. They can end up at both ends, or they can end up in the middle. Yeah. All right, so go ahead for me now. As per usual, you guys are going to get a minute or so. I think a minute and a half is due for this one. Go ahead and see. Yes, question.
Sorry, just a moment before you move on.
Sure.
If during, okay, so an exam, instead of writing by the minus 20x squared, you had written minus 20x again. You write, so instead of writing x squared, it will be considered as wrong.
Run that question by me again.
How we have minus 20x squared? If you
Yeah.
don't write the squared, but instead you just write out minus 20x minus 20x, that's considered wrong?
Yeah, because minus 20x, that's minus 40x.
Oh.
So minus 20x minus 20x, that's minus 40x. Minus 20x times minus 20x. And that's not to be right. So if you want to write out this answer a different way, it would be, yeah, you just can't write it like that.
Okay, sir.
Yeah. All right, so go ahead and try this one for me. Expand and same instruction, guys. Expand and simplify. 2 minus 4y. I'm changing the letter. You don't want to get too comfortable with this x business, you know, because it's not always going to be x. 2 minus 4y. 3 plus, what's going on here? Okay. 3 plus 5y. Go ahead and simplify that. Expand it and simplify it for me, please. I'm going to give you a minute and a half. But I feel like I'm rushing, but I just needed to understand the importance of working these questions in an amicable, a suitable time frame, so you don't overthink. Remember, we train how to deal with exams in a timely manner. So certain questions, when you see them, if you run through them quick and fast. I'm putting on an extra minute. All right. So give it a little bit more time than what I expected. But anyways, let's get into it. Here and there, there and there. So the 2 times the 3 is going to give us 6. And the 2 times the 5y is going to give us 10y. And negative 4, that's the inside one now. Negative 4y times 3, that's negative 12y. And the negative times the positive is negative. 4 fives is 20, and the y times the y is y squared. If you have that, you're good to go. For this example, you can see that the two like terms end up in the middle, fortunately for us. So the answer is going to be 6 minus 2y minus 20y squared. All right, let me check the chat and see how many persons have gotten it right. No someone in the group are talking. Oh, nobody. Oh, Sasadin, jump in. Okay. You can give me a thumbs up if you got it right now. If you don't want to type it out. I'm not
Sir,
seeing the thumbs up. Yes, question.
you know, work it out in my book and type foolish in the chat.
I'm so sorry. Ouch. No, oh, you mean a foolishness? Oh, hold on.
Where you get a 2?
Sir, I have 6 minus 2y minus 20y squared in my book and write foolishness.
So what did you write in the chat?
Oh Lord, I see me want glasses.
I same thing. Everybody have the same answer. Natalia, Nicolita, Latisha, Adair, Sasadin, Dominic. You all have the same answer. It's just that you wrote it in different order, but it's fine. So the order doesn't matter, guys. Because look at Ajir's answer. And then look at Sasadin's answer. Ajir had the 6 at the end. Sasa has the 6 at the front. They both have the 2y in the middle. And then you have Latisha, who have the 2y at the front, the 6 in the middle, and the 20y squared at the end. Order doesn't matter, as long as the signs are correct. So good job, guys. All right, so there's one that I want to ensure that I go through before our time is up. All right, so you kind of get the idea, but it does need some practicing. It's not something for you to take for granted. All right, it's not hard, but if you don't practice it and cement it, next time you see it, it can look like foreign. So before we end the class, we have another 6 minutes or so. Okay. This is not loading. You understand? Taking away my 6 minutes from me. All right, here we go. Sorry, guys. I don't know why my device was freezing. Why is it taking so long? Okay. I don't know why it took so long. All right, so there's one more example. Apart from the ones that you're seeing on screen here, there's one more example that I want to make sure that I go through. All right, students tend to overtake this one when they see it. So here we go. Expand and simplify. Oh, where's my eraser? Okay. All right, so all right, here we go. So expand and simplify. expand and simplify, and it's going to look like this. X plus 4 squared. Yeah. No, let's make it a little bit more challenging. Hold on. 2x plus 5y squared. So when students see this, I guess, it's easy for a math teacher to say this is easy, but when you're a student who is not a big fan of math, when you see this, it's kind of tricky. All right. So 2x plus 5y squared. Let's look at the common mistake that students will make. They'll square the 2, square the x, square the 5, and square the y, and say it done. Incorrect. You can't do that. All right. So you cannot square the 2, square the x, square the 5, and square the y. That's the most disastrous way of getting the question incorrect. All right. So you don't want to do that. So I'll put that out there. All right. Now, to understand this, what this means, ladies and gentlemen, is that when you square something, you're multiplying whatever that thing is by itself. Now, pay attention. Remember, now we said that 2x is not separate from 5y. This is a binomial expression. So they're binded together. They're together. You can't separate them. So 2x plus 5y cannot be visualized as 2x and 5y. 2x plus 5y is one thing. For example, if I ask you to write down an expanded version of 5 squared, what would you write down? Expand 5 squared. I don't want the answer, but how else could you write 5 squared?
5 times 5.
Very good. 5 times 5. So what you notice that I did here, I took the number that is being squared and I multiplied it by itself. Not true? All right. So if 5 is being multiplied by itself, then that means since 2x plus 5y is basically one thing, they're tied together. What this implies here is that this is going to be 2x plus 5y times 2x plus 5y. So hopefully you understand what that means when you see it, if and when you see it in the future. So 2x plus 5y implies, 2x plus 5y squared means 2x plus 5y times 2x plus 5y. Now, just in case there's somebody in the class that's asking if this number will ever be 3, not at the CSEC level. It can be any amount of number, but it's not at the CSEC level. At the CSEC level, the maximum is going to be 2. So let's go ahead and finish this, guys. First, second, right there. So let's go ahead and simplify this now. 2x times 2x, that's going to give us what? 4x squared. 2x times 5y, that's going to give us, well, 2 times 5 is 10. And x times y is xy. All right, so 2x times 5y, the 2 times the 5 and the x times the y, so that's 10xy. Now, middle piece now, 5y times 2x, the 5 times the 2 again, that's going to give us another 10. And the y times the x. If you want to write yx, you can, but conventionally we write them in alphabetical order, so that's xy. And in the last term, now we have 5y times 5y, that's going to give us 25y squared. There. And as usual, the like terms usually ends up in the middle. Because we have 4x squared, and we have 25y squared. Careful. I know someone we said insert in 2 and a squared. So we can add them together. One is x squared and one is y squared. So they are unlike. But the ones in the middle are both xy's. So they are both alike. So the answer is going to be 4x squared plus 20xy plus 25y squared. And that's your final answer. Okay? All right. We've had a long class and it's been a long day. So let me just update you. Next week, Monday, I'm going to send you a worksheet that consists of, I'm going to upload a worksheet. I'm going to text you in the group of a worksheet that consists of, it's not due, but it's something that you can practice on. It consists of all the topics that we have done in algebra so far. All right. So the add and subtract, the multiply and divide, and the distributive law and the binomial expansion. So we're going to have a worksheet with probably about maybe 8 questions or so that reflects all that we've done in algebra so far, so you guys can keep up to speed. So when we return here next week, Monday, what we're going to be doing is that we're going to be moving on to what is called algebraic fractions. All right? Algebraic fractions, along with more practice questions. All right? So that is it, ladies and gentlemen. I want you guys to have the rest a productive, peaceful, prosperous rest of the evening. And I'll see you guys on Wednesday for another session. All right? Have a good night.
Good
You too,
night.
sir. Thank you.
All right, good night,
Good
sir.
night.
Good night. Good night, everyone.
Right, sir.
Good night.